P38 MAP kinase that you heard about this morning from Holly Brown-Borg and from Jim Joseph. And then when we verified that, we did a dose response curve, and you can see here's control. And as you add more of this inhibitor, you get a progressive increase in lifespan. So this has given us quite a few targets. Another one is protein kinase A inhibitors work extremely well. And Peter Rodent just published a paper, actually, just came out, showing that protein kinase A knockdown mouse has an extended lifespan. So we think that's very interesting and a good target for study. So now I'd like to talk to you about our mouse study. I have no idea how much time I have left. I'll keep forging ahead. So we have 60 treatment groups. There are 293 controls and 36 mice per treatment. Our statistician told us that that would give us a 1% probability of a false positive and an 80% probability of detecting a real changer. And the reason we can get away with so few treatment mice is because we avoid the Bonferroni multiple testing correction by comparing the treatment groups only to the control. So we can tell if they're changed relative to control, but we can't say what they are relative to each other. So that's a way to avoid having to do statistically their correction. It gives you much more power statistically. We use all males. We started the treatment at 12 months. We use a chemically defined diet, and I'll talk to you about that just for a moment. We feed them daily. We note any uneaten food, and then we feed them only their daily allotment the next day. And we try to figure out how to compensate for that and get them to eat all of their food, and that's been a lot of work. So I'd just like to tell you about the literature that's out there briefly. So I found 82 studies where they used healthy rodents to screen drugs or nutrients for their effect on lifespan. 21 of those 82 are contradictory melatonin studies, so I don't consider those here. 12 of the remaining 61 studies had no effect. One showed a shortening of lifespan, and that's by feeding high-fat diets, which makes mice diabetic and shortens their lifespan. And then 19 of the remaining 27 have other compounds. 21 of the 48 remaining, you cannot tell from the data that's given whether or not CR was an artifact, or else it's obvious in the data. I would encourage those of you who are doing lifespan studies to please measure the food you're feeding the animals. Never say, oh, the weight wasn't different, because you don't really know what that means. You don't know when the weight was measured, how often it was measured, how many were measured, what the statistic used was. It's really impossible to evaluate 21 of the 48 studies. 19 of the remaining 27 studies had egregious compounds in them. They were unrepeatable either because it was impossible to tell what had been administered. The number of animals wasn't specified. In a few cases, they didn't even tell you the species, whether it was a mouse or a rat. They just called them animals. I mean, it's just amazing how bad this literature is. Only 2 of the remaining 8 studies here actually measured food consumption and found a lifespan effect. And so I think this is sort of indicative of how hard it is to really find something that truly changes lifespan, where you can exclude CR as a possible contributing factor. So, I've already made this comment. So, our 60 groups have several hundred compounds. Some are single and some are combinations. The food's administered daily. Yes, we remove unconsumed foods. I would just like to say, when we fed ad libitum at the start of the experiment to find out how much the animals would eat, we had the food is packed with the supplements, so the supplements packed in the food. We actually monitored how much they ate, and 35 of the 60 diets were underconsumed when they were fed ad libitum. We had to actually lower the amount of calories that we're feeding to about 80% of ad lib to get most of the animals to eat all of their food. So if you think a mouse is not discriminating in what it eats, you're very wrong. We found they're highly discriminating. They don't like changes in their diets, and they don't like a lot of things. That's the trouble with Drosophila studies too. There are many compounds that are insect repellents, just like DEET is. And so if you're putting an insect repellent in your Drosophila food, they eat less of it. So it's important to use that cafe assay of Seymour benzers and find out what they're eating. I think this literature, all of this literature, is really highly confounded by CR effects. And we could not taste anything wrong with these or smell anything wrong, but the mice can. And so this is just a list. We have 2 CR controls, because some diets, no matter how hard we tried to make them eat it, we put bacon flavor in it, which mice like, we cut down the total amount. They still won't eat all of their food, so we use these 2 controls. And these are just, we're doing a sandostatin injection that lowers IGF-1 levels, and we've measured those. Bromcryptine lowers growth hormone levels as well as prolactin levels. These are CR sort of like effects. Cyproterone acetate lowers androgens. They give this to like sex offenders, a pellet of this stuff is long lasting. An iodine-free diet with methimidazole and perchlorate that makes them hypothyroid. And then we've added those together as well, trying to chemically reproduce the effects of calorie restriction on these major signaling systems. We've done a statin and an ACE inhibitor, an angiotensin receptor blocker, which is even better than an ACE inhibitor, and combined these beta-adrenergic receptor blockers we use as well. There's evidence they may extend lifespan. Lavoisier, which is this prescription fish oil, in essence. Nicotinic acid. We're using everolimus, which is like the rapamycin, which you've just read about, probably extending the lifespan of old mice. A very important discovery of the NIH ITP program. And then some others as well. I won't go through them all, so thank you very much.